So good afternoon, sir. Myself Swati Sonia and my team partner is Ankita Gupta. For our self-study topic for DSP is beat detection using MATLAB. So we have used a MATLAB program for beat detection. In this, what we do in this program, we upload a audio file and accordingly we detect the beats in that audio file. So there are different algorithms that can be followed. One is the time domain algorithm and the second one is the frequency domain algorithm. So in time domain algorithm we find the energy and then we kind of we get the threshold of the energy and accordingly we compare the frequency with the help of the frequency domain algorithm. So if we look into the steps of the beat detection, first we load the audio file. So in the program we can see, so we have used an audio read function. So basically this what this function does is it gives two output. So the first output it gives is the matrix of the audio samples. So we have uploaded this song and so it
only dot wave format it will support?
Yes sir, only dot wave format. Okay. So the Y, there will be two output given. So the Y output will give the audio sample and the FS will give the sampling frequency of this audio signal. After we have loaded the audio signal, we pre-process the audio signal. So in pre-processing, basically what we are doing is we are changing the amplitude such that it always be between -1 to 1. So we are normalizing the audio signal what we have loaded, which can be further, we are giving it to for the feature extraction. So
why -1 to +1?
So because it's a beat detection, so it will be easy for if we normalize the audio. So if we keep it from -1 to 1, we can know the threshold. If the beat is more than that, we can say the beat is high or low, we can compare it. So only it should be always between -1 to 1 for the comparison purpose. It's a threshold. So we normalize it and then we compare it. For the other process for feature extraction and other, Ankita will explain the process.
What we are doing is we have one song or any kind of audio file. So we are trying to find the frame size, like what will be the allowable frame size, so that this hop size function in MATLAB will give us the allowable frame size. Then what will be the number of frames in a particular window will be given by this frame size function. So that we are doing. Then after that, what we are trying to do is we are trying to calculate the energy, so that what we are doing is we are calculating energy is equal to sample frequency square plus some standard deviation, because there might be some error, right? So we need to give some deviation from our side, so that will give us a total energy. So now for each beat that is there in the audio signal, a particular threshold will be set. Above that threshold, if the energy is above that threshold, a beat will be detected. It's like that. So like for only something above a certain threshold, there will be a beat detected. Which will be calculated with this energy formula. So we are detecting the beat. That is a beat detection algorithm. Like if the frame energy is greater than a certain threshold, it's finding beats. Then what are we doing is we are plotting two graphs. One graph is giving us the amplitude of the audio signal for with respect to time, and the other graph is going to give us the detected beats for at what time what beat is detected. So for example, what we have done is. So we loaded one particular audio file, and then for that we were getting results like this. This is the audio signal. These are the beat detected in this frame size, and this gives us the amplitude of this audio.
Frame size, what frame size of this total record?
Sir, it will depend on the size of the.
Automatically it will select that frame size, or you have to mention
No,
the
we have
range?
We have given.
It will select, sir. According to this function, it will select.
Yeah.
Depending upon the hop size.
The tool automatically will select,
Yes.
or you have to give the range? I am asking you.
No, sir. We have given it 1024 and 2048.
Is there any specific reason for selecting that numbers?
No, so it's not like we can give whatever window we want to.
What frames you are interested?
At what distance the beat should be from each other. Depending upon that, we can give the frame size. Like if you want the beats to be more distance from each other, the frame size could be more, so that you can easily view the graph, or you can compact the frame size.
And also energy calculation you said, okay?
Yes. Sir.
For that any retrieval tool is there, or you use any
No, sir,
logic?
we have used a formula. For each sampling frequency, we are squaring the sampling frequency, then adding it with a certain deviation. like to correct the error that can be there. So like some threshold we are already adding with it, so that like if there is some error, it will be adjusted. Because like sometimes it won't detect, right? Even if energy is there, it's not detecting. So that's why we are giving some there. So that energy calculation, the formula is over there. So there is no predefined function as such.
All this part of the graph on this arrows.
So this is that thing. This is the threshold that we are specifying. Depending upon the frame energy, the threshold will be specified. Like it will be different for each frame. So with that, if the frame energy, like the total frame energy in addition with the threshold is greater than the threshold energy, like then the beat will be detected. Then there will be a beat detection as shown in the graph. That's why you can see only even if there is song going on, right? But still at only certain points there are beats detected. So if it's greater than the threshold, then only you can see the beat. Like in the amplitude, there are some vibrations there, but the beat was less than the threshold value. So that's why no beats were detected initially.
Okay, where it will be useful further?
So what we can do is like light control using this algorithm. Light control with sounds are there, right? According to the sound's vibration, the lights can be fluctuating.
Intensity of the light.
Intensity of the light can be fluctuating. In that areas, we can use this,
Use it.
and we can normally see how the graph or the sound will look like in music industry and stuff.
What made you to select this particular application? So many applications are there. What is the specialty in selecting this kind of particular application?
Sir, there are already products in the market, like normally just for entertainment purposes, in which the light fluctuates according with the songs. So like that fascinated the idea, like how are we doing? What is the idea behind it? How exactly is the light relating to the sound that's being produced? So with this energy, because of the energy fluctuations, the intensity of the light also fluctuates in relative to the energy fluctuations in the music.
Can you use a sort of application for in operation theatre, healthcare?
Yes.
In healthcare, doctor will be doing operation for 2 hours, 3 hours, heart and other things.
Yes, yes.
Okay, as sunlight and other lights increases, automatically the intensity of the light should reduce or increase according to the need. Can it be interlinked to that?
So according to the sunlight, will be using some.
No, whatever. Okay, suppose in this room I put curtain.
Okay, sir.
Okay, I don't want
So
to
what
put
we
curtain.
can use instead of like we are using this music file right now, right? What we can use, we can use an LDR sensor or something which can detect because of the change in intensity of the sunlight, the resistance value will change, right? So according to the because the resistance value is changing, we can sense that change in the value, and with respect to that, we can control the intensity of the operation theater, lights in the operation theater.
Say suppose in 100%, 60% intensity is contributed by a natural light source. Okay, you have to remaining 40 should come from the light source. Suppose 40% is from natural source means 60 should change. Totally I want 100% of light illumines in that operation.
So what we can do is like there's a particular pattern which the sun is gonna follow every day, right? So
That's why your sensor should detect automatically.
yeah, that's it. So
like beat or your intensity pattern.
Yeah, so like here we are sensing the energy changes, right? In that we can sense that resistance value changes
like
how
that.
it's changing. So with that, like,
Concept of the application is same. There light intensity here, the beats magnitude. And what DSP techniques you adopted?
so we are normalizing the frequency
Okay.
based on -21. The sampling frequency value we are using for calculating the energy value of each beat.
Okay. And any further plan is there to enhance this work?
So we can, as you said, we can either try with how with the change in resistance values, we can change the light in the room, or we can try with how the change in energy can control the intensity. We can try on hardware applications, like this is on the civil link, right? So we can actually see how it's affecting. Like,
Okay. Through this self-study, what other thing made you attract while searching applications?
so searching application, like we learned also about like this is something which we made, but then there are also other things that we learned like speech recognition, image processing, which like there are so many applications of DSP in real life which we can actually just with the normal use of software like or Python code or MATLAB simulate. With such codes, we can see on our laptops like how the DSP is implementing normal.
Means that the intention behind that it is across the globe. different people will be working on different applications, different softwares. You get to know through this study process.
Yes, sir.
Okay, that is the motto. Okay, thank you.